Okay, so base times height here, and we also need to multiply our 4 times 2x, and that's equal to 8x in particular. And 4 times negative 3 is equal to negative 12. Okay, make sure you get those signs in there. The next thing I want you to do is highlight the like terms inside. So these are the like terms. You guys can see them. 8x, negative 15x. You know that area is composed of 4 parts. This little guy plus this guy plus this guy plus that guy. So the area, bless you, equals, put it all together, 10x squared minus 15x plus 8x minus 12. Okay? But since we're looking at combining these two, right, we can put that in our brain calculator, and what do we get? It's a negative because there's more negatives. Negative 7x minus 12. Good.
That's what I got.
Make sure you go ahead and plug that into your calculator to double check your work. Thumbs up if that makes sense. Okay, so Miss Sanchez is going to go over just the answers for numbers 17 through 19, okay? So, same process, right? You should have done this for homework. A lot of students like doing the box method, so I am just going to go like this. That guy goes there, and I multiply that guy to both. So that's x squared, that's x, and I do the same thing here. Yeah. Good job, Jaden. And therefore, our area is x squared plus x plus 2x plus 2. We got some like terms here. So therefore, this equals x squared plus 3x plus 2. Okay, I know I'm going over these very quickly just because you should have done these for homework. Number 18, if I zoom in, Miss Sanchez is trying to get you guys ready to go into higher level math, right? Geometry, Algebra 2. So I want you guys to maybe think about the box in your head and what's happening. So this is technically your base, and this is your height. So base times height. You're going to go ahead and want to multiply this term, first term of the base, times the first term of the height. That's what you should do. That is equal to 12x squared. Then you take that same base, but you multiply it to the second term of the height, which is equal to plus 8x. It's just a shorter way instead of doing your box. If you don't like the fancy distribution or the distribution arrows, you don't need to use them. You can use box method if you'd like. But again, I just want to show you the different ways to multiply polynomials. Number 19, I am not going to use my box. I am going to use that. Okay, this is my base. This is my height. So therefore, I am going to take this guy, multiply it by that guy. First term of the base times first terms of the height, x squared. And then I'm going to just go in order. The first term of the base is multiplied now by the second term of the height. That's negative x. Now I take the second term of the base, right, the bottom of the house times the first term of the height. And then same thing. Okay, and then maybe if it helps, I'm going to do this. Negative 5x. There you go. You combine like terms. Squared minus 6x plus 5. Okay? And that is your answer. A trinomial, 3 terms, and in particular, it's a quadratic. Okay, any questions on these so far? Okay, so whenever you're asked to find the area of a shaded region, which is this shaded area right here, there are a few steps we must take, okay? So first, I want you to consider this poster board, and I'm coloring it in blue. What are the dimensions of this poster board? What are the dimensions of that poster board? All like this guy. There you go. Those are the dimensions of the poster board, the big one. But let's say for this project, I needed you to insert things through that poster. Like things had to go in the poster and out of the poster. So in order for something, or for you to put your head inside this poster pretty much, you have to cut a certain area out, right? So we have to cut this area out. This guy inside, cut it all out. Whenever we cut something out, right, this guy right here, what is happening? Are we adding, subtracting, multiplying, or dividing the areas? We're subtracting, right? Because we're taking away. We're getting rid of that. So what I want you to do is help me write this down. So in order to calculate this, I need to take the area of the big rectangle, subtract the area of the small rectangle, and that should give me what?
The area of the shaded area.
Just of the shaded region, right? I think that's pretty cool. Right, you have a big poster and you want to cut off an area. That's going to give you the border, right, or the outside. Okay, good. So Miss Sanchez likes to teach you guys how to be organized. So you're going to make a 3-column. 3 columns right here. On the left side, we're going to calculate the area of the big rectangle, okay? So we're going to calculate the area of the big rectangle. That's going to go over here. And it's base times height. And like you guys said, that is equal to 2x plus 7 times x plus 5, yeah? Does that make sense to everyone?
Yeah.
So can we multiply and get the terms?
Yeah.
Okay, let's do it. We get 2x times x is equal to 2x squared. 2x times 5 plus 10x. 7 times x is 7x. And 7 times 5 is 35. We got to combine like terms. We get 2x squared plus 17x plus 35. All right, looks pretty cool. We got those 3 terms. You could also use your box method, right? Either way works. Okay, and then we gotta go on this side and calculate the area. So this is the area of the big, area of the small rectangle. Same thing, base times height. And what is that? Does anyone wanna give that a try? What are the dimensions of the small rectangle that we wanna cut out? Anybody know the dimensions?
X minus 2 and 4.
Yeah, 4x times x minus 2. Those are the dimensions, or the factors. Therefore, when we distribute, we get 4x squared minus 8x. Okay, so now what do? We put these two ideas together, right? We take the area of the big, right here, of the big rectangle, and then we take the area of the small, right? And we get, okay, 2x squared plus 17x plus 35. We substitute the next one. We got to make sure we bring that minus, right, the minus sign, and put parentheses because there are 2 terms, and whenever you have more than one, you always put parentheses, okay? It's kind of like when your parent tells you to wear a helmet when you're riding a bicycle or a tricycle or an e-bike or anything like that. You got to put your helmet on, right? When you're riding something that has more than one wheel. I don't know. Something like that, in order for you to remember that you need to always put parentheses when you have more than one term. This just means you're gonna have to take the opposite sign of each term. In other words, you're gonna multiply by a -1. So here we go. Since I didn't do anything with this guy, I'm gonna bring it down. And what do we get here? We get the -1 times 4x squared. That gives you a -4x squared. And -1 times a -8x. That gives you a +8x. All right. And then I had a student last period tell me, like, Miss Sanchez, I don't like the way you wrote it. Like, whenever I distribute, I always like to go ahead and move it. I know this is similar to that guy, and this is similar to that guy. In other words, they are like terms. Can I put like terms in one column, like one on top of the other? And I said yes, 100%. Okay? So therefore, we go ahead and combine 2x squared minus 4x squared is equal to -2x squared, and then you can do these two. And this is your area of the shaded region. Isn't that cool how this was a two-part problem? Yes, this is step 1 and this is step 2. And this is the final work, step 3, is putting it all together.
I thought it was positive.
For which one? Sorry.
For the one that we just made.
Yeah, it's got to be, it's a negative leading term right here. It's a -2x squared. The reason is because of this. We just distributed. Okay, so with that being said, any questions on this problem? Okay, so I want...
GCF.
There you go. Thank you very much. Write that in. So all these problems here, these are just examples for the 2 terms, the 3 terms, the 4 terms. I'm going to walk you through 2 examples, maybe even 3. But I just want you to get familiar with the process that you've done before, okay? You guys should be pretty, you guys should catch on to it really quickly. So what method do you use to factor? Well, we always use the X method or the diamond and then the box. So our first step is always to label. So what's my A value and my B and my C here?
A value is x squared. A value is x squared.
Raise your hand when you know.
A value is 1.
Yes.
Oh.
A value is 1. There's only one of the X squared tiles. What about what's your B?
0.
And C?
64.
-64. Thank you, Jeanette. So therefore, we can use, let's see if we can use our X. Okay. And we know that A times C goes on top, and then B goes on the bottom. So 0 goes down here, and then we get -64 up here. So what are 2 numbers that multiply to -64 and add to 0? -8 times 8, okay? That gives you -64, and they add to 0. We found the 2 numbers. So in other words, these magic numbers, this is going to be a 0 pair. A pair is when you have 2 things, and 0 means they, you put them together, -8 plus 8 makes 0. So we just went from x squared minus 64 equals x squared minus 8x plus 8x minus 64. They are the same because this is a 0 pair. We turned a 2 term into a 4 term, okay? So I don't have extras. So therefore, we go ahead and now slap it into the box, okay? So we put our x squared minus 8x minus 64. And we find the factors. Does anybody know the factors? Yeah, so I like how you said x times x gives you x squared, and then one's a minus 8 and one's a plus 8. So therefore the factors are, so x squared minus 64, it equals x minus 8 times x plus 8. There you go. You guys see how we took the 2 terms and turned it into a 4 term by using the 0 pair? Yeah, but the only way we knew it was a 0 pair is because of the diamond. Okay, so let's move on to, if you want to give yourself like the method, it's diamond, and then what did we use?
Zero method.
No, box method. We didn't use 0 method. We had 0 pairs. So diamond and box method. Okay, so now we look at the 3 term, and let's go ahead and label A, B, and C. So what's A equal to?
1.
And then B is 6, and C is 8. We want to see if we can use a shortcut, but we'll come back to it. The answer is yes, we can use a shortcut, but let's see why. So let's start with the long way. So let's go ahead and A times C is equal to?
8.
And B is 6. So therefore, here we have to find the 2 lucky numbers, and what are they?
4 and 2.
Yeah. 4 times 2 is 8. 4 plus 2 is 6. So then we can go ahead and put them in the box. All right, we turned a 3-term polynomial into a 4-term polynomial. So it went from here to here. All right, this little guy got split into those 2. Pretty cool stuff. So now we can put that in the box. Right? And what do we get here? Well, we can work backwards. X times x, 2, and 4. So therefore, our factors are x plus 2 times x plus 4. So there is a shortcut, and why can we use the shortcut? Because what?
No.
Did we even ask ourselves what the GCF was?
No.
No, but Miss Sanchez already knew the GCF was 1. And how did I know that really quickly? Because A is 1. Good job. Whenever your A value is 1, or in other words, the amount of x squared tiles that you have is 1, you'll know the GCF is always 1, because no other number divides 1 besides itself, 1. So when you have something like that, you can always use the shortcut. And what is the shortcut, Jackson?
If A is 1, then there's no GCF.
Yeah, and then do you know how we can get these factors really quickly?
You just do the negative of the number,
No.
or the opposite of that.
No. Maybe some of you don't know the shortcut, but it's okay. You do the long way. If you discover it, let me know and I'll tell you if you're right.
Define the factors.
Uh-huh. It's a really shortcut. Really good shortcut. So let's go ahead and try the next one. Is there a GCF here? No, right? I mean, there's a 3, and then you look at the one right here. There's a 1 there, right? 1 for the B tile. So that's when you're like, oh, if there's a 1 anywhere there, I know that the only number that divides 1 is itself. So therefore, the GCF does not
0.
exist, or it's just 1. Okay, so therefore, the shortcut, can we use it? In this case, we can't.
We can use diamond.
You can use diamond. You can always use diamond and always get the right answer. Negative 12, 1, right? 3 times negative 4 is negative 12, and then 1, then 4 times 3 is 12, but one of them has to be negative. Yeah, one of them has to be negative. Good job. Then we go ahead and now we created 4 terms. Don't forget, you're taking the first term, top left, then you get your magic numbers. They go in the diagonal, and your ones go right there in the bottom right. You get x times x, but one of them has to be a 3. This one, because this column has a GCF of 3. And then make sure you take out a negative 1 here, okay? So then here the factors are 3x plus 4 times x minus 1. Okay, any questions so far? Oh, it doesn't want to work out. Okay, so what do you guys think I'm going to do for the 4 terms? Just slap it into the box and find the factors, and then you're done. Okay?
And this 15x, I just combined those little terms, and I got that. Just like pretty light.
Okay, awesome. And then why is it that you ordered it from like in that order? So 5x to the 4th minus 3x to the power of 3, and then so on and so forth.
Oh, it's like in standard form, you like just like do that. So I just like decided to.
Okay. So I like that word, standard form. And what does standard form tell you?
I honestly don't know.
Do you see the order of the exponents? It's going from x to the 4th, x to the power 3, x to the power 2, x. So whenever you have descending, like from highest exponent to lowest exponent, that means you're in standard form for the polynomial, okay? So very good job. Let's give him a round of applause. Yeah, so let's see. I am writing this down for a lot of you, so there's a minus 3x cubed. So for those of you that can't see the board, I'm writing this down. So let me. So all of you should be writing this down. If you don't have it written down, you will not get the points for today, okay? Okay, so I'll give you about a minute to work it out by yourself. There you go. Okay, since I just finished copying, I didn't copy it down. I worked it out my own way. And then I noticed that Ryland's method and my method, like we both ended up getting the same answer with either method. Okay, so anyone want to present number 22? Let's go, Carlos. You can take someone for support if you would like also, right? Okay.
So what I did was I wrote like the column first, and then I wrote parentheses x minus 9 parentheses, and just did the same thing again. And then after that I squared the x, and I made that negative 9 times negative 9 is 81, and then that's what I got for my answer.
All right. Does anyone see? So why don't you work it out? And if you see an area where this group needs to improve, let me know. Any areas of improvement? I'm working it out by myself. Just kind of, I'm not saying whether your answer is right or wrong, but I mean, it's good to always double check, right? Using our own method. If you don't like the distribution arrow method, then you can use your box method, right? Carlos, do you mind showing us with box method up there what you would get? On the exam, you should double check your work, right? so many arrows. Maybe I should do this. That's why, there you go. All right. And raise your hand if you see an area that needs improvement. Do you think everything looks good? Anyone want to do it? Let's see. You get x squared. You get minus 9x, minus 9x, and then 81. So you're, oh, okay. So do you guys,
Positive 2.
what happens here with the diagonal, Carlos?
You do x minus 9 and x minus 9.
Yeah, so what is that in your calculator, in your brain calculator? Negative 9 plus negative 9.
81.
No, negative 9 plus negative 9.
No. 18.
Is it positive or negative 18?
Positive, because 2 negatives make a positive.
Ooh, good
2
question.
negatives make a positive.
It's addition.
So you got 9 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 more negatives. How many negatives are in total?
18 negative.
18 negative.
Yeah, so it's negative 18x plus 81. This is a common mistake that happened in all of my periods, okay?
That's what that-
Number 23.
7 jumped down at the R, and 7 jumped down, and I equals negative 49. I wrote it out as 9 squared minus 7R plus 7R minus 49. And these two cancel out, positive and negative, so my answer was R squared minus 49.
It's right.
Okay, so do you guys see how here we have a positive 7r and a negative 7r? They're opposite terms, so therefore they cancel out. It's a 0 pair, right? Because this gives you 0. Okay, so your answer is, just like Chris said, r squared minus 49. Round of applause. Okay, let's go to the next one, number 24.
X minus 8, so we just put it on the left side, and then obviously you like get x squared, and then x times negative 4 is negative 4x, and then negative 8 times x is negative 8x, and then negative 8 times negative 4 equals 32. So then you put those all together, and then when you like simplify it or whatever, you get x squared minus 12x, and then plus 32.
Yeah, I do want to point out it's not or whatever. It is simplifying. You are combining like terms, so very good job. So I do want to notice. I'm noticing a lot of the box method that's getting you guys the correct answer. So use the box method, okay? Try, the fancy distribution, the one with the arrows. Maybe one time, see what you get. Maybe practicing a new method always makes the brain grow.
Yeah.
Yeah, good job. Okay, I'm glad to hear that. So let's try number 28. I'll do 27 with y'all, don't worry.
Multiplication, you get 10, and adding them together, you get 7. Put it into the box with in the top left corner, x squared, then 5x, 2x in the bottom left, and in the bottom right, 10.
Okay. Any questions for Everly's group? Looks good. Can you guys double check, see if there's any areas of improvement? I'm working on it my way.
It looks good.
It looks good. Nobody has any questions? All right. Did you see any errors?
That is supposed to be negative.
Ah, there you go. Do you guys see that? I was working on it by myself over here because that's what we're supposed to be doing, right? We should give it a try ourselves and then compare and see like, oh, it looks like Everly is on the same pace as I am, on the same page. But then I looked at hers and was like, wait a minute. I see a -7 for the B, but she saw a +7. So always double check those answers. On the exam, guys, since it is multiple choice, I will put one of the answers as x minus 5 times x minus 2. Another one could be the opposite of that. It could be x, so trying to I try and not trick you guys, but I try and put the possibilities that are really close to each other, right? So the other one could be x plus 5 times x plus 2, and your brain will want to be, it's that one. But no, don't be fooled. Double check the signs. Okay, round of applause. Did we give you one already? 29 now.
X 1, B was negative 14, and then C was 48. And then you put that into the diamond method with 48 on the top and negative 14 on the bottom. And the two numbers on the sides was negative 6 and negative 8. Then when you put that in the box, on the top left it's x squared, top right it's negative 6x, bottom left it's negative 8x, and the bottom right it's 48. And the factors were x minus 6 times x minus 8.
Could we have used a shortcut here? Oh, you guys don't know the shortcut, huh? I'll let you guys discover it. Some of you might remember, but yes. A lot of people in my third period and some in my first period knew the shortcut.
Is the shortcut for 29?
The shortcut can be used for 29 and the shortcut can be used for 28, but not for 31.
So it can be used for 32.
But you don't even know it, so it's like,
Yeah, I know.
exactly. So just, when you find it, let me know. Okay, number 30. Who's doing number 30?
You do that new bag.
Go Lincoln. Go Lincoln.
Alright, our problem was factor x squared plus 7x minus 18. And then for the first step, we did the diamond method. So, and then the top was minus 18 and the bottom was 7. And we got, the two numbers we got was 9 and negative 2. And then, so we put those in the box. We filled everything in. We put x squared minus 2x, 9x is minus 18 in the box. We figured out the factors, which was x plus 9 and x minus 2. 30.
Excellent. Let's give him a round of applause. All right, 31.
So our problem was factor 3x plus x minus 2. So first we plugged these numbers into the diamond problem, and we got 3 and negative 2, so we put them in. So we put our numbers in the box, and then our factors were x plus 1 and 3x minus 2.
All right, and so can you tell me do you want to write down A, B, and C there for me?
Yeah.
All right. And you can see oh. There we go. All right. So, any questions for Jackson? Any areas of improvement? Okay, let's give him a round of applause. Good. So let's go ahead and do number 32 now.
So there wasn't a GCF for the equation, so I did the A, B, and C, and I got 2 for A, 7 for B, and 6 for C. Then I plugged it into the X problems, and I got 3 and 4 for the magic numbers. And then I put those into the box, and my factors were 2x plus 3 and x plus 2.
All right. Any questions for Kayla? Or any kudos? No? Okay, I do. I want to say that she's the first person to say there's no GCF. Like, I know a lot of you, like, know there's no GCF just based on the terms that you're given, but she was the first one to state it. Like, there's no GCF, right? Jackson, you're moving right here next to me. So bring your stuff right here. So, therefore, you guys, I just want you to follow the rules, right? The steps, right? The first rule, the first step is to check for GCF. If it passes that, great. So, yeah. So hurry up and get your stuff, buddy. Let's go. I'll write you a referral right now if you don't get up.
Get my stuff.
Okay, because look, I have it right here.
Gotta find my pen.
Okay.
Right here.
Yeah, right there. So thank you, Kayla. That was excellent. I'll give you some time to copy it down. There we go. Remember, you're going to be turning this in for points today. Next group, number 33.
So I followed the same steps as Kayla, noticed that there was no GCF. Then I identified my A, B, and C. A was 1, B was 0, and C was negative 49. And then I did my diamond method and put 49 at the top, 0 at the bottom, and my two numbers were 7 and negative 7. Then I did box method and filled it up, and I got, as my factors, x plus 7 and x minus 7.
Any questions here? I think that was amazing. Round of applause. So thank you for stating the A, B, and the C and that there was no GCF. I really liked how you found them, right? 7x, negative 7x. And you notice that it's x plus 7, x minus 7 as your two factors. So very good job. Started it. Some of you started it. Great.
The last one, 35.
For the whiteboard activity, yes. See, that goes on top, okay, of the diamond.
Okay, wait, so we actually did it wrong again.
Okay. Yeah, I mean, it happens, right? When you get these problems on the exam, just make sure you double check your work, that you put the right A, B, and C value. And once you do that, you should find two numbers that multiply to negative 100 and add to 0. You will notice that they are opposite terms. So therefore, you get, these are your two factors. Okay? So let's give them a round of applause. And do you guys want to do number 35 or did you?
Cubed minus 16x squared minus 3x plus 12. Like we took all those values and put them into the Punnett square.
Okay, I love that, the Punnett square. In our class, it's called the area model.
Okay.
Or the box.
And then
It's cool, it's cool.
then we like factored outwards.
Okay, and what'd you get for your factors?
We got 4x squared minus 3 and then x minus 4.
And then you got x minus 4.
Or wait, I mean negative 3x. Or yeah.
Okay, so you get 4x squared minus 3, and then x minus 4?
Negative 3x minus 4. Or wait, no, x minus 4.
Good, good, good. It has to be x minus 4, right? Because 4x squared times x gives you the 4x cubed. Okay, okay. So box in your answer, and let's give them a round of applause. All right, let's look at this one. It's an example. Below is a two-way frequency table, which shows the data collected of 2,000 subjects. Answer the following questions using the two-way frequency table. So, what I'm going to do is, first of all, I'm going to finish filling in this table. Oh, Chris, what did you get for this first row for the strangers? Or for the relationship was a stranger?
118. I mean,
1,118?
Yeah.
Okay, let's go with Emily. What'd you get for the relative relationship row? So relationship is relative. How many? $787. And then unknown, let's go with Carlos.
95.
And if you were to add this column, what would be the total? 2,000. Very good job. Okay, now let's add up all the columns. The homicide, the robbery, and the assault. Let's go ahead and do that. So let's go with Lincoln. What'd you get for the homicide? How many total homicides were there? Okay, 69. And then robberies. How many total robberies were there? Let's go with Everly.
505.
Okay. And let's go with Paige. How many assaults were there?
I think I got this wrong page.
Okay, double check. 1,426. Okay. So, what is the joint relative frequency of people that were victimized by a stranger who were robbery victims? So this one's a really good one because whenever you see joint, you should think of the two variables or the two incidents occurring, okay? So two occurrences happening. Stranger homicide, relative robbery. So that's everything but the totals. So we're going to put them all over 2,000. It's part over whole. The total or the whole is 2,000. Okay, 2,000 subjects. Okay, I filled it all in, okay? Now, we got to look for is a stranger, by a stranger who, so people who were victimized by a stranger who were robbery victims. Stranger, and then we got to stop at robbery. Oh, right there. The intersection. So it is part over whole, and we already have that. The part is 379 over 2,000. If you were to put that into a decimal, what would you get? And then the percent would be that. Right there. All right. Now, letter B, it's marginal relative frequency. So we got to look at the totals, right? What's in the margin right here. Okay. And of people that were homicide victims. So if we look here, we look at the homicide and we look at the margin. How many is that? Well, we got to make sure it's relative frequency. So these are also out of the total. Out of the whole of 2,000. So therefore we have 69 over 2,000. What did you get? Zero 0.0345%. Sorry, 0.0345, and then I'm going to turn it into a percent. And it's 3.45% approximately. Not bad, right? Now it's asking for what percent of people were victimized by a stranger. So if we look for stranger, right? So I'm going to look here. And I'm gonna look at the total. How much? 1,000, right? Look at the comma. 1,118 over 2,000, right? Over the total people.
0.559.
0.559, which is equal to 55.9%. Very good job. 55.9%. Some students are putting 55.90%. That's okay too. I don't mind it.
They printed it out.
Okay, so what is the conditional relative frequency that a person was victimized by a stranger if, or in other words, given that the person was a robbery victim? So whenever you see the word if, right? If the person was a robbery victim, so you look at, that's going to be your whole, the robbery victim. So here, hold on, right here. So you're going to look at robbery, and then how many in total were there? Yeah, so part over whole, and it's going to be 505. And then how many of them were victimized by a stranger? So you look here, and how many of them were victimized by a stranger, guys?
Teacher victimized.
You look in the same thing. Given that you're in the robbery, right? The person was a robbery victim. Right. What's the probability that a person was victimized by a stranger? It's 379.
It's so hard for me to understand the questions because of the way they word them.
Yep, that's how statistics is. So it is 0.7505 if you want, which is 75.05%. Okay, so